Hello. This will be a demonstration of Proposition 27 from Book 8 of Euclid's Elements, which says that two similar solid numbers are to each other as two cube numbers. Or in other words, the ratio between two similar solid numbers is the same as a ratio between two cube numbers. All we're given are two similar solid numbers, A and B. A and B are both solid numbers, and furthermore, they are similar. What we want to prove about them is that the ratio between A and B is the same as a ratio between two cube numbers. That A is to B as a cube number is to a cube number. Now, because A and B are similar solid numbers, we were given that information. We know by Proposition 8.19 that two mean proportionals must fall between them. That proposition tells us that between any two similar solid numbers, there are two mean proportionals. So A and B, being similar solid numbers, have two mean proportionals which fall between them. The next step is going to be taking these mean proportionals, call them C and D. C and D will be the two mean proportionals between A and B. So that A is to C just as C is to D, just as D is to B. Furthermore, we're also going to make the four numbers E, F, G, and H such that they are the least numbers in continued proportion in the same ratio as A, C, D, and B. We can, of course, find them by Proposition 8.2. So E, F, G, and H are the least numbers in continued proportion in the same ratio as A, C, D, and B. And because they are the least numbers, we know that their extremes are cube numbers. That's what the porism of Proposition 8.2 tells us, that if a four-term continued proportion is in least terms, the extremes are cube numbers. So that E, F, G, and H being a four-number continued proportion in least terms, E and H are therefore cube numbers. But we also know that E is to H just as A is to B. We arrive at this similar to the previous proposition 8.26 by a use of proposition 7.14 about xi-quality proportionality. We know A is to C just as E is to F, C is to D just as F is to G, and D is to B just as G is to H. Therefore, xi-quality going between the mean terms of C and D, then F and G, we compare the extremes directly to say that A is to B just as E is to H. But we know E and H are cube numbers. We have just proven that in the previous step. So A and B are to each other as two cube numbers, namely E and H. And this is exactly what we set out to prove, which means we're done with the proposition. Therefore, etc. Q, E, D. An example with particular numbers would be that 12 is a solid number that is similar to the solid number 96. This is because you can represent 12 as a solid with side lengths of 2, 2, and 3, and you can represent 96 as a solid with side lengths 4, 4, and 6, so they are similar. And because they're similar, this proposition tells us that the ratio of 12 to 96 is the same as a ratio between two cube numbers. And this is easy enough to verify. 12 is to 96, just as the cube number 8 is to the cube number 64. So we see that the two similar solid numbers, 12 and 96, are to each other or have the same ratio as the two cube numbers 8 and 64. Now with that said, that ends the final demonstration of Book 8. This is the last proposition of Book 8, which means after this, we'll be heading into the final book of Euclid's number theory, Book 9. I'm excited to get into it. There's lots of great stuff in it, including the 147 of Euclid's number theory, which is, of course, exciting to get into. So I'll see you all then on Proposition 9.1.